football games. So there are many changes to the 2018 code, but I do think that we were successful in making some changes that bring more benefit to new homes to Virginia, but limiting some of the cost impacts for your future home buyers. So the 2018 code, as far as timeline, um, it's looking like it's going to be effective this July 1st. But don't worry, from its effective date on July 1st, builders have 1 year to comply with the new code. So this means that you're going to have 1 year to comply with the new code. So meaning July 1 of 2022. Today, we're going to be going over one of the major changes to the code, which is the requirement for all new homes to pass a blower door test and achieve 5 air changes per hour or less. The current code does require that homes achieve 5 air changes per hour or less, but the requirement to actually have the homes tested is the major change. I do want to share that there was a strong push by many to reduce the air changes per hour to 3, but our advocacy efforts made it possible to keep it at 5 and just have the test as the requirement. Anytime there's a major change like this, HBAV first looks to make sure that we have enough service providers in Virginia to test all 20,000 plus homes being built each year in the Commonwealth. After we did a detailed search and vetting, HBAV identified a service provider for the entire state that is also local to Virginia and is a longtime member of the Home Builders Association of Virginia. That service provider is PEG, who you're going to meet today. PEG has worked with HBAV to not only provide blower door testing for all builders in Virginia. So regardless of where you are, PEG can do your testing. Also, they've agreed to do it at a reduced cost for HBAV builder members compared to their shelf pricing for non-HBAV members. And probably most importantly, PEG is offering free training like you'll have today. And in the future, we hope to do in-person on-site throughout the state. They're not only a service provider, but a true resource for HBAV members. And their track record of success is really a shows their commitment to customer service and our industry. Today, you're going to hear from Matthew Cooper, who is the Senior Vice President of PEG. He'll be training at 2 homes today, a pre-drywall and a home that's ready for a blower door test, which you'll see here at the end. We also have with us Jamie Dovell with PEG, who is Virginia Area Market Manager. Many of you may already know. With that, I'm going to turn it over to Matthew to get started. And if you have questions during the program, just type them in the chat and we'll try and answer them as we go. If we don't answer them as we go, we'll circle back and catch them at the end. So thank you, everybody. And Matthew, I'm going to turn it over to you.
Good morning, everyone. Thank you, Craig. As Craig said, my name is Matthew Cooper. I'm a Senior Vice President of PEG. We're a engineering firm and energy efficiency firm based out of Fairfax. We work in 27 states. We're licensed engineers in all 50 states for mechanical, electrical, and plumbing. Today, we're talking about IECC code blower door testing. We're going to walk you through 2 homes. We want to thank Van Meter for giving us access to these homes today for us to be able to provide this virtual training. The first house is going to be a house that's ready for insulation, has not been air sealed. So our field inspector, Aaron, who you'll meet in a moment, is going to walk you through his typical field inspection process to show all the best practices of areas in the home that need to be air sealed in order to most successfully pass a blower door testing, which takes place at final, which he will also be showing you in another property. As Craig said, our area manager, Jamie Dovell, is on the line here as well, and he's going to be answering questions that are typed in. As we move from the pre-drywall house to the final house, he's also going to be sharing some of the forms that we use as part of our inspection and testing process. So it'll be something that you might be able to get a little bit more familiar with and what you would expect to see if you're working with us. As Craig said, we're a little under 200 people based out of Fairfax. We are a Virginia certified woman-owned business, and we've been Energy Star Partner of the Year with the EPA's Energy Star for Homes program for 10 years in a row now. We conduct about 80,000 residential inspections every year for energy efficiency, whether for code or above code programs, such as HERS and Energy Star and the National Green Building Standard. So our folks have a great deal of experience with working in a lot of different climate zones, a lot of different types of construction, in helping our builder partners be able to successfully meet these code requirements. So with that, I'm going to turn this over to Aaron, and he's going to take you through this house. And like I said, we'll spend probably about half an hour here, and then we'll move to the final and go through the actual blow door testing.
Hello, everybody. My name's Aaron. We're going to be walking through this house, looking for issues and problems that will lead to air sealing issues and infiltration problems on your final. So the first place I want to talk about is the garage. Most overlooked, problematic space. A lot of the subcontractors that come in don't consider these two walls here exterior, because they're inside of a garage, but they should be considered as exterior walls because the thermal boundary of the house begins and ends at these two walls. So the first thing you want to look at is your sill plates, where the wood meets the concrete, and then above on your banding, okay? So this house doesn't have conditioned space directly above the garage, but if it did, you definitely want to see full blocking and sealing along this outside rim above the walls. Also, if the interstitial space of your garage comes up, basically this is the basement right here. So what this builder had to do is install T-ply and seal it. So the best practice, this wall is going to get drywall attached to it. Okay, so the best practice isn't to foam from the outside, because this foam is going to keep the drywall away and allow for air infiltration. So the best practice would be to staple this T-ply on the banding for the basement and then go into the basement and foam it from the inside of the house. And we'll take a look at that in just a moment when we go to the basement. Okay, so that takes care of the garage. The next space we're going to go look at is the basement. So won't you please follow me? Okay, so these foundation walls provide pretty good air stopping ability. So what you want to focus on down here is any penetrations through the foundation and anything above the top of the foundation wall. Okay, so what I'm going to show you now is that garage banding we just looked at. You can see the T-ply showing through here. It would be the best practice to foam from the inside instead of the outside. So you can see how you can kind of see a little more daylight on the inside here. So if you're foaming from the inside, you'd be able to pick up those daylight spots a lot easier. Also, can you get that up any higher to look at where that wood meets the concrete? There you go. The top of the foundation wall and the sill plate where they meet should have a foam gasket. Now, I understand that gasket is supposed to stop moisture and air, but the issue with that gasket is the top of the foundation wall and the sill plate aren't always exactly flat and straight. So it's going to leave kind of little gaps here and there. So we recommend, in addition to the sill seal, to foam the concrete to the wood. Okay, now this is kind of a unique situation here where the foundation of the house, the foundation walls stop at the back of the house, and then you have framing installed. And obviously this transition transition here is leaving a lot of daylight. It's pretty obvious that will need to be sealed up. Just being inside your homes and looking for daylight is going to go miles for your infiltration testing. Another thing that would be a good practice here. Let's say that we were in a townhouse and this is the slab and this is the sill plate. You'd want to foam right in here and get it nice and sealed so no air can come through, seep through on a low spot or a weird spot on the sill plate. It's like like mechanical exhaust for the furnace. Everything that needs to blow outside is pretty obviously running through the rim and band and will need to be sealed. This is something that's really easy to check for before insulation goes in. So if it's possible to do your air sealing before insulation, that's ideal. I know some builders contract the insulators to do the air sealing. So you kind of have to keep an eye on how good of a job those insulators are doing if you're paying them to do the air sealing as well. Because a lot of times some stuff can get hidden by the bat. Hidden by the bat. So instead of sealing it, they'll just kind of hide the daylight and move on. Okay, so that's the basement. Let's go upstairs. We'll talk about exterior doors and windows. So all exterior doors and windows should be sealed, set and sealed. So like squared out. You'd see, if you look closely here, you see it's got the shims in it. So it's kind of half set. It's been shimmed out, but it hasn't been foamed. So it's kind of halfway there. So all of the windows should be set before you hang the drywall. All of the exterior doors as well should be set. So you can get a nice seal so you don't get drafty windows and doors. So this is a really good gap right here. So that's going to take a good amount of foam. Okay, so we are above the basement. So this bottom plate right here on the exterior wall going all the way around the house, it should be sealed as well. I know a lot of people will do this, will glue this to the subfloor, but not glue the garage wall plates to the subfloor. So you kind of want to create an envelope where air cannot escape. So you're essentially building this envelope, and that envelope obviously requires these two garage walls to be treated like exterior walls. It's just another thing I'd like to bring up here is this knee wall. You have framing on a really high wall. It doesn't have bad insulation installed yet, but I know when it does get put in, it's not going to have any air barriers installed because of the roof truss framing. It's a good idea if you have these really massive knee walls that are being insulated to have them framed in such a way that it will provide contact on all 6 sides of the bat. Because over time, if it doesn't have that T-ply against the back of the wall, the bats will sag and fall, and then the wall will not be performing as it should be. The next thing I want to look at are a few penetrations in a chase over here in the master. This is kind of a big deal because this chase has ductwork in it, and it's going to be pulling hot and cold air through the ductwork, which is probably going to be the opposite temperature of the air that's in the attic. So if this chase right here doesn't get sealed up properly, it's going to fill up with attic air which could lead to condensation, eventually mold growth, not to mention allowing attic air into an interior chase is going to hurt your infiltration rate. So another thing to really pay attention to is blocking at tops of chases that are adjoining unconditioned space and sealing all your penetrations going through the top plates where you have unconditioned space above. Also, it's a great idea to install a drywall gasket, which is basically an 1/8 inch bead of flexible caulking you can install at the top of any top plate that has attic space above. It's super simple, easy, quick thing to do that you can have done before your drywall guys come. A lot of the builders contract the drywall installers to install the gasket themselves, and it's my experience they don't do a really great job with it. They either use a gasket that gets punched up into the attic space because of the way it's installed, so it's not really acting as a gasket, or they'll run a bead of caulk and it won't dry before they put it up, and then it ceases to be a gasket. So if you just get in there a day before, you can do it whenever you want. You just install your drywall gasket. That way it's done, and when your hangers come by and put the drywall up, you don't have to worry about a bunch of attic air getting into your walls and making you fail infiltration. All right. So we talked about exterior doors and windows, the basement, the sill plates, the band board in the garage. Don't overlook your garage. That's a big deal. A lot of these infiltration tests, if they're right on the line, can pass or fail with that garage door being open or closed. So, you know, the tighter your garage is, the easier time you're going to have with passing infiltration. All right, let's go upstairs for the last part. So right here, you have a bathtub joining an exterior wall. It doesn't have T-ply behind it. So this is going to allow, you know, cold air to seep under the tub. And when the homeowner fills that tub up with nice hot water and it goes cold in 5 minutes, they're not going to be too happy. So it's a good practice to have the T-ply installed before the tub. That way you can have the T-ply coming up past the lip of the tub and it would actually perform well. So now we're on the top floor of the house. Here's another chase, kind of similar to the one in the owner bedroom. It has plumbing through it. The blocking at the top of walls isn't sealed. Again, this little chase is going to fill it with cold air. And if you look, the plumbing penetration goes down to the first floor too. So this is a high-speed expressway for attic air to get down to all the way down to the first floor, just like that, if it doesn't get sealed up. So communication, cutting down communication between attic space and your envelope and the garage space in your envelope are going to be two keys on having successful blower doors. And then one final thing I wanted to talk to you guys about is when you have like attic space that has like roof sheathing that's cutting in to an attic space, or a divided attic space where there's some sort of barricade or wall preventing you from going from one side of the attic to the other, it's really important that you provide a man-sized hole, some kind of pathway. All right, I've seen this a bunch of times where whole sections of the attic didn't get blown in because there's no hole, man-sized hole through the roof sheathing. So like in a situation like this, if you can show them, there is somewhat of a little hole there. But once the drywall gets hung up, that hole is probably not more than 2 feet tall. And then you got the framing running through the hole, which makes it probably only a foot tall. So I always tell the builder, you know, and he does it too, to make this hole bigger, make a new hole. You want to look around and make sure that your subcontractors, you're setting them up for success, that they can get into this space and blow it in. Because if they can't, they're not going to call you up to tell you. They're not going to say, hey, there's a part of the attic I couldn't. They're just going to pack their stuff up and leave. So number one thing here is giving your subcontractors a product that they can work with and that they can make better for you, and then you can make it better for your homeowner. Okay, that pretty much concludes the walkthrough of the pre-drywall. I can't really hear anything, so are there questions or anything like that?
Jamie's been answering some questions in the chat here.
Okay, all right, fair enough.
Yeah, I don't know, Jamie, if you want to elaborate on them, or if you're gonna, I know we're gonna share your screen as they head from this house to the next house. You tell me.
Yeah, I'll answer some stuff. Some of the things I know that Aaron talked about, maybe that he didn't show really well, is when we're really trying to stop the communication from conditioned space, that inside of that envelope from that unconditioned space, especially on the upper floors. So things like electrical penetrations, plumbing, ductwork. A lot of times you will see, the electrician will come in, the insulation company or whoever's doing your air sealing is going to come through, and they're going to seal, the major parts of the electrical. The ones that really get missed a lot of times are those of the low voltage. So if they have like security systems, speakers put in, those kinds of things, they usually come after most of the trades have been there. They're kind of an afterthought. So what happens is it doesn't look like a lot of holes, but when you start getting into houses, that are only 1,200 square feet, those little holes start to add up when you're going for a blower door. Virginia is very lucky as far as it being 5 air changes. If you go into other places such as Maryland, where it's 3 air changes, it gets extremely tight to try to pass those blower doors. So those are things that we're really going to be looking at, again, to prevent that communication from conditioned to unconditioned space.
Yeah, and here's one more thing that I didn't cover that I wanted to talk about are the electrical junction boxes. Another quick, easy thing you can do is foam all of the punch out tabs and the penetrations through the box, because that's going to be a direct pathway into your envelope. And if you think about how many outlets and light switches there are in these new homes, it's like crazier than Swiss cheese. So if you're confident in your wall assembly construction and you're like saying, hey, there's no way air can get through there, just do a blower door and put your hand over an outlet and it'll humble you real quick. So foam in the backs of these boxes is something that they've been doing in Maryland for a while, and it really helps them achieve that 3 air change rate.
Yeah, I mean, one of the biggest things is you won't see it so much on single family homes. You will feel it on single family homes, but when you guys get to townhouses and condos, and that kind of stuff, the common walls, they leak. In the place that you find that the air's coming through is through those receptacles. So it's always a great building practice to foam or seal those from behind on the tabs. One of the big things too, he did talk about, it wasn't didn't see a very good picture of it, was the top of the walls, especially where the duct chase is. One of the things when the vendors or the subcontractors are coming in and they're cutting holes to run their piping, a lot of times they will cut the holes twice or 3 times the size that it actually needs to get in. If you talk to your subs and say, hey, cut the size that you need, maybe a little bit bigger, but not too much bigger. It allows for easier air sealing. If not, then you have to go up and you got to block, and then you got to air seal, and it can cause other issues in other areas, and things get missed. So those are some of the big things as far as that going, as far as air sealing goes. I am going to show a screen for you guys of just kind of how our inspection report looks like. We have a couple different ones that we do, really depending on the type of inspection that you guys would want to do. Just for code compliance, we have one that just meets just for code compliance. We also have those that will, for HERS ratings, and then also Energy Star and National Green Building Standard as Mr. Cooper had talked about earlier. Let me share my screen here. As you guys can see, this is one of our inspection reports. This is for a different builder. And so what happened is you as the builder would get this inspection report. It comes in with the division, community, and lot number, and what type of inspection it would be. It also has, obviously in the construction business, things happen where things have to be canceled, and it gives an option to cancel the inspection or not for the builder or for the rater when we get there for the builder. It also will give whoever your project manager is on site. It gives us our project managers. It gives us the client email address. This is all put in through a scheduling, through scheduling, and this will automatically be sent out to you as the builder, who it is. So kind of just some of the general information, real quick: date, whatever the model type is, lot, address, the state, and then what county or jurisdiction, and then also what type of foundation are we looking at? Is it a slab, crawl space, or basement? And then the orientation of the house, because the orientation obviously makes a difference for her score. This particular house is a pre-drywall under the 2015 code. We do have things where at pre-drywalls, if a house is failing the code requirements, we do smoke a house to find the issues so that we can point our builders in the correct way of how to fix that issue to meet the requirement for duct testing. Our reports look something like this. I'm going to have a picture of the manometer of what we tested, where we tested at in our setup, what the results were, along with who the inspector was, and his phone number and his certification. We also look at visible mold or suspected fungal growth. Things are wet. Obviously the picture, this is kind of a pre-drywall. And the reason why we're going to show you this is we'll also show you the final, but the pre-drywall, we take elevation photos of the home, and we're going to talk about the insulation values for those homes. But also in here, this is where our air sealing information, if we find deficiencies in a house, it's going to be noted on here. Any kind of thing like rim and band, what is the R values, the grading of the R value, what kind of insulation it was, pictures of the overall of your house. Let me see here if this one had, what window types. I'm looking to see if it had, I just kind of picked one, doors. So one of the things too on the report, it will go through, hey, raters verified the overall alignment through the house, the garage, air sealing, was the air sealing of the rim and joist done, and was it done correctly? I should say. And then we're gonna, things that, like if it's in your house, drop ceilings and so forth. One second, I'm working in an actual house that's being worked on. Energy Star sticker, obviously we put that in, and then if the house failed for whatever reason, we'll come back. And so just to show you what a final house would look like. Trying to find one here. 1 second. Okay. Sorry, on the call, if you guys could. Can you guys still see this?
Yeah, we got you, Jamie.
Okay, perfect. All right, so this would be a final inspection, what we'd be looking at for a final inspection. Again, it's all really the kind of the same stuff as we're going through with the builder, you know, just their information, the model, and so forth, what we're kind of looking for. And then total leakage, again, we do our setup and photo. And then what we're getting ready to talk about, we do multi-point testing instead of a single point testing. You know, you can do either one by the standard. The problem is if you do single testing, you have to add 10%, which typically is saying, hey, you as the builder, you got to be 10% better than what you were. And so that causes a lot of times that causes issues, and it's a cost to you as a builder to try to get 10% better. Multi-point is a much better practice. It allows to take 8 different readings across a matter of an expand. We start at 60 all the way down to 17 or down to 10. It gives us numbers, and then it gives us what the average would be with the corrected temperature value for temperature and for elevation value. And then we obviously just take the picture of the biggest number, but we also show kind of a setup of the duct blaster being set up, which Aaron will be doing and showing here momentarily when they're ready. One of the things that we look at, we're going to look at distance above sea level. We're going to look at what the temperature of the outdoor temperature is, indoor temperature, and then there's a correction factor that's all going to be put in there. Our testing procedures are compliant with the 2018 IBC, the 1301.1.
Never mind, she let me back in.
Say that again, I'm sorry. And then, you know, are all the codes. As you can see, this particular house that I'm showing, you know, we went through the numbers and got to correct it. CFM 50, with the volume of the house, it came out to an air change of 3.38. This house was super tight. I would say that the average blower doors or infiltration tests that we see in Virginia is somewhere around 4 to 4.5. You know, when you're that high, then, you know, there's a very small thin line that it is to fail. So, you know, this one being at 3.38, the builder did a little more than what the average bear would do. Then obviously pass and pass. Aaron's here. He's getting ready to start showing and setting up. So I'll kind of turn that back over to them. Do you guys have any questions?
Yeah, I don't know if you saw the question. I'm pretty sure you are, but I'll let you answer Jay Epstein's question about, are you able to certify for the 45L tax credit?
Yes, we are. Yes, we are. We do all that.
And cost, I know you've got set costs. I don't know if you want to send that out afterwards or if you want to go over that now.
Yeah, as far as costs go, that's really not my expertise. I don't do the pricing. I can find out for you guys, and kind of we can send that out on what that would cost to do the 45L tax credit and testing. What it would cost for testing.
All right, good. Any other questions before we get to the next presentation of the blower door? I think that's it. You think, are they ready? Is Aaron ready, Jamie?
Aaron, you ready?
Do we want to do the setup of the blower door or walk them through the house to set the house up first?
Let's do the walk through the house, and then we'll do setup. So he's going to walk you guys through the house of what he's looking for, and then from there we're going to he's going to set it up. I don't know if you guys have seen blower doors set up before. Some of you guys might have or might not, but he's going to just kind of walk through that process of what that is. And what it looks like, and then he's going to test the house, and we're going to see where we're at on this particular house, and we'll go from there. Concrete penetrations. Are we talking about through the concrete, or are we talking about like just, you know, concrete where the wood meets the concrete.
Through the, with your, when they're drilling holes for your HVAC to go through a foundation wall, what's the best way to seal that concrete? Because sometimes they put conduit and then they have your line sets running through there. What is the best way to have that 100% sealed to pass these blower door tests?
Yeah, I would say a closed cell spray foam. The ones that we typically see, they don't come actually through the concrete itself, like the concrete wall. It's usually above. It's usually above in the rim and band is where they're coming through, and that's where they're spray foaming those conduits or those condensation lines.
Okay, thank you.
Yes, sir.
All right.
Yeah, and Alan makes a good point on the chat, guys. Making sure that you use the correct foam for the project that you're looking at. Low expansion. You don't want it to expand too much around windows and doors. You don't want to knock it out from being square. And then stuff like large gaps or holes. Using a more high expansion foam to make sure that you're getting a good seal is best practice. All right, I'm going to turn this over. I'm going to stop talking and turn this over to Aaron and them.
Okay, guys, we're in kind of the same house, but not really. What we're going to do real quick is we're going to run through this house and get it ready for an infiltration test. All right, so much like a realtor, I'd like to go upstairs first. That way we don't have to climb 2 flights of stairs when we go into the basement. So the first thing I'm checking for is that all the windows and the doors are closed. So you want exterior windows and doors closed and interior doors and windows open. Now, the only exception to this is something like a closet that doesn't have any windows or exhaust fans. You don't have to open those up. But if the closet has a window or some kind of ventilation, not ventilation, but like an exhaust or something, it needs to be open. So all bedroom doors open. We want to check the bathroom for exhaust fans running, and you want to make sure all of your exhausts are off. Okay. This may seem a little obvious, but you want water in the toilets, water in your plumbing traps here. That's a ResNet standard. If you don't have water on the house and you try to get a blower door test, you're gonna suck all that air that's in the sewer. You're gonna suck that into your house, and it doesn't smell very good. Also will hurt your infiltration rate. So now that the upstairs is set, also one thing I didn't touch on up there was the attic access. You want to make sure that that is in and gasketed. All right, exterior doors and windows closed, interior doors open. See, we got a running exhaust fan here. Okay. And then we'll go ahead and close the garage door. All right, we're gonna pretend to close the garage door because there's a truck hanging halfway out of the garage. All right. And then we'll check the basement real quick. I guess you go around here to get to the basement. Big deal. This door obviously leads to a whole different section of the house. Obviously needs to be open, not closed. Okay, looks good down here. Windows and doors, exhaust fans. I think we're all ready to go. Looks good in here. Okay, so if your furnace has a fresh air intake on it, it's probably a really good idea to make sure your furnace is not running because it's pulling in probably 150 CFMs while it's running. All right. Okay, and here's let's show these guys. So check this out. So this is how Van Meter foams their basement banding. So they don't have to worry about box sealing, little things here, or penetration there. I love this spray foam because it seals everything and insulates. It's a 2-for-1. So it's a great thing to see when you're a raider, when you come in and you see that expansion foam laid in there. All right. House is ready. It'll just take me a moment to get this little red door installed. While I'm doing that, it's a good thing to know essentially what this process does. So that's a reference hose. It's just measuring the atmospheric pressure outside of the house. But essentially, if I was gonna dumb down this infiltration test, I'd tell you that we're blowing air outside of the house. So if this house is a balloon, a rigid balloon, we're gonna try to deflate the balloon, okay? And the amount of air that escapes out of the house when we put it under pressure is your infiltration rate. Now there's a couple different kinds of infiltration testing. We do a multi-point, which takes 8 different measurements at different pressures, and then we calculate an average. All right, so in order to accurately measure how much air is coming in and out of the house, we gotta run what's called a baseline, and that essentially just measures the static pressure of the outside atmosphere and the inside atmosphere. So when it's depressurizing the house, it can factor in atmospheric pressures and kind of negate them from the equation. So the first thing I need to do is a baseline, which is measuring those 2 pressures. So we got all the doors closed, Jamie? Okay. Getting ready to run the baseline. Okay. So depending on, okay. So this is how we're gonna set the manometer up. Just turn it on, go over 1 to pressure flow. It's on blower door 3. And I'm gonna say this house is super tight. So I'm gonna start with the 3-ring baseline start. So now I'm running a baseline, I'm measuring the pressures. And what it's telling me right here, the difference is 2.3. And this is the seconds on this side. So as it's counting up, I'm watching the pressure. And if it's climbing or dropping rapidly, you want to run a longer baseline. If it's staying right about the same, 30 seconds is plenty of time. So we'll go ahead and accept that. And Jamie, do you have a form we can put this data into? All right, so I'm gonna go ahead and start taking measurements by, again, drawing air out of the house and measuring how much air, how much of that resistance there is, basically trying to deflate a rigid balloon and how hard it's fighting me, or if it's just gonna collapse and let me suck all the air out. So at the B ring, work my way up. All right. So you can see there, definitely shouldn't start with the B ring on this house. So I'm gonna go to the A ring. So the first measurement I'm looking for is 10 pascals of pressure, and it's gonna tell me in CFMs. how much air is coming in. So at 10 pascals, we're at 2142. Let's see how loose this is. I feel like something's open. Oh, come on. Hey, there's an attic access up here that got sucked open. So if you want to show them that while we try to get it fixed. So just with 10 pascals of pressure on the house, the wall access got sucked out. So right now I can't depressurize the house because this is all attic space that communicates with outside. So I'm gonna have that screwed back in or reinstalled in order to successfully conduct this test. There's a wall access that got sucked open. It wasn't screwed on. You just want to hold it while I run it? All right. Okay. So with, oh, see how tight that is now? All right. So yeah, back to the A ring like I thought. B ring. All right. So with the access panel closed and the B ring, which is a tiny little hole, I'm able to depressurize the house to 10 pascals at 560. That's respectable. Way better than 2100, which is what we were getting with that with the access open. Okay, so we'll go right up to 17. Ooh. Okay, 24. 24. Those were again 980. 31. Okay. So I've gotten several measurements. I just got to make this hole bigger so I can move more air to get the rest of the measurements. So it's 1150, 38. So sensitive. Let's go 1330. 45. 3 more measurements. $52. 15. So, and then the last one, 60. All right, that's it. 1752. It's now 40 degrees out. Okay, yeah, we're good, Jamie. All right. Overall, it was a very successful test. I have to calculate volume, but I can tell just by looking at the numbers that it's probably under 3 air changes. I'm working out the volume right now. Yeah, but the infiltration test literally takes like 10-15 minutes, so it's not a huge deal. Shouldn't be too invasive on your scheduling. But it's just important that the raider who's coming by kind of has the house not to himself, but at least to where he can have everything closed for like a good half an hour to an hour. It would just make everybody's life a lot easier, because if you have cleaners in the house and one of them's upstairs, cracks a window to clean it after the raider has already walked through the house and made sure everything was good and runs it while the window's open, you create an issue. Not saying that the raider wouldn't know that a window was open, but you just never know. So it's better safe than sorry when running your air testing. Okay, I'm gonna hand you back over to Jamie. And I'm gonna calculate volume. See if there's any questions.
Alrighty, guys. Any questions that you guys might have ran that you might have?
Jamie, we can't hear you. Can y'all hear me?
Yep.
All right, Jamie, we can't hear you. I don't know. All right, somebody who's next to Jamie, let them know we can't hear him. Well, while we get Jamie's volume, I guess, worked out a little bit here, or his microphone. I appreciate everybody being on the call. As you can tell, I think PEG has proved that they're truly experts in this field, and there's going to be some training between your subcontractors and your ultimate testing company. I know PEG can help you with that, and we hope that everybody considers utilizing them for their service. We'll definitely continue to do some more trainings whether it's virtual, which appreciate everybody bearing with us. I think PEG did a good job, but virtual has its challenges. We'll try and do some around the state in person. We'll ask some builders to let us use their houses and be scrutinized a little bit. So on that point, I also want to thank Van Meter for letting us into their house and let us perform this test. So Jamie, is your microphone working yet? No, I can't hear you. I don't know if you want to answer just in the chat. But I think that's does anybody have any other questions? If you do, can you wrap? I see if you have a fresh air system, do you check it as well? That's obviously a question, not for me, but for the PEG folks. Jamie, you just want to type that one back? We'll distribute. We've got some flyers and the correct information to make sure anybody on here and really any HBAV member in general gets the HBAV pricing and the service that PEG has been kind enough to offer. So please consider that. We'll distribute that, and this webinar is being recorded also, so we'll send that out. If there are Jamie, do we have anything else that we need to present? Or are we wrapping up here?
Hey, Craig, it's Matthew.
Yep.
I think we're pretty much wrapped up.
Hey.
Jamie, are you there now?
Yeah. Oh, go ahead, Matt, and I can go after you.
No, please go ahead and wrap up.
Sure. A couple things I was saying was that if a house doesn't have power, we run extension cords from a neighboring house over to get the blower door to test a house, or the builder will usually have on-site power generators there for us to use to test. One of the things, as you can see, what was that number, Aaron?
2.7.
And this particular house, the air change for this was 2.7, so a pretty tight house. Things like attic knee walls not being screwed in or sealed can obviously cause, you've seen during the testing that, it went to 2,100 all the way down to 580 CFMs just for the first number. So things like that is things that we're going to be looking at and diagnosing if issues come awry. And then obviously if a house fails, as a company, we will give you guys the best solutions to fix the problem and the most cost efficient ways to fix those issues to get it to pass going forward. Other than that, as far as fresh air systems, we do test fresh air systems. We do everything. We test, Brone, April Air, all of them. So we have tools to do all that during the testing, and that is tested during our final inspection. What was some other questions that you guys had that I could answer?
I think that's all that came through the chat. I mentioned that I'll send out Jamie's information, Matthew's information, everything you all need to contact them. And if we've got more questions, they can email you directly, I guess, if that works.
Yeah. So my direct line, if you guys, I'll type it in the chat for you guys, is going to be 540-276-3259. Our office number is 703-934-2777. You can always reach out to myself at jdovell@pegemv.com. And we can go through whatever kind of testing or things that you would like to do for your company. Those are ways to reach out to me. And then we can go from there and we get you put in contact with the right people.
Awesome. Well, thank you, Jamie. Thank you, Matthew. And I guess it was Eric who did our tour for us. So appreciate you all. I know everybody's time is valuable, so we'll wrap up. But again, we'll send out information and contact. So as you start looking into testing your houses and getting ready for compliance with the new code, hopefully you can work with PEG. The last thing I want to leave you with is I mentioned that PEG is a member of HBAV. As an associate member, not a builder. They support our association. We need membership more than ever right now. Even though we kept construction essential, our membership is down. So if you're doing business with anybody building your houses, if you can please just ask them how important it is to you to be a member of their local HBA, which makes them a member of HBAV. That would really help us. Without membership, we really are nothing. So we need to really focus on that. That's all I have. Matthew, is there anything else? Otherwise, we'll wrap this thing up.
No, I think that pretty much covers everything. We really appreciate the opportunity to do this virtually with the hiccups that it comes with, but we are looking forward to doing the live training around the state, and just stay tuned for information from HBAV on the dates and times for those events. And we'll get everybody in following safety COVID protocols and get some live training going so that we can get everybody prepared to be ready, anytime between this July and next July.
Great. All right, everybody. Thank you. Stay safe. And again, thanks for being a member of HBAV.